Now let's take a look at factors affecting reaction rates. Reactions are due to collisions between atoms and molecules. So in general, the more frequent the collisions, you would expect a faster rate. Okay? But you have to realize that not every collision is going to lead to a reaction. Sometimes, okay, the atoms or the molecules colliding don't have enough energy for that would lead to bond breaking, okay? And so there's a minimum energy you need for the collision to lead to a reaction. That minimum energy that you need is called the energy of activation. So if you have more energetic collisions, that means in general, the higher the temperature, the faster the molecules are moving. If you have more energetic collisions, you would expect a faster rate. So in general, when the temperature increases, you would expect faster rates. You have faster movements, more frequent collisions, more energetic collisions. And like I and even though they might have the molecules might have enough energy to actually uh, react. Okay, sometimes if they're not oriented the right way, okay, when they're not approaching each other in the correct positions, then the correct orientations, they may not actually react. So there's another fact. That's another factor that needs to be considered. Okay. All right. So in general, how is rate reacted by higher temperature? Higher temperature means, in general, faster or slower? Faster. Higher concentration, would that generally cause faster or slower rates? Higher concentration. So imagine this room is more crowded. Are you more likely to bump into someone? Yeah. So more frequent collisions would cause more generally faster reaction. Okay. Now, what if you increase the concentration of one of your reactants and the reaction rate doesn't go up? Now, that gives you a clue as to what's going on at the molecular level. Maybe it doesn't matter if how much of that particular reactant you have. Maybe the mechanism of the reaction is such that there's a process there that's happening that doesn't depend on that reactant, which controls how fast the reaction goes. Okay, so that, like I said, making measurements of rates gives you clues about what's going on at the molecular level. What about surface area? If I had a block versus a powder, which one would react faster? In general, the powder would react faster because you have more frequent collisions. You got more molecules exposed, right? Whereas in a block, the molecules inside your block are not exposed to the other reactants. Now, one way you can monitor the progress of the reaction in the lab is by taking a sample of the reaction mixture. So you carry out a reaction in the lab, right? Mix them in a test tube or a beaker. And then you take a sample at different times. So let's say 1 minute later, you take a sample. Now, what you need to do at that point is to know how much of the reactants and products are in that sample, right? So it takes time to actually do that determination. So what you need to do is you need to immediately quench that reaction. What does quenching mean? You need to find a way to stop that reaction at that moment in time, okay, before you do your analysis. What does analysis mean? To analyze something means to determine how much of something is in there. So you might want to monitor how much reactant you have left. Okay, so you analyze your sample. Quenching, okay, typically you do it by dumping your sample into an ice water mixture. Why do you think that quenches the reaction? So I have a reaction mixture, I take a little sample of it, I dump it into an ice water mixture. Why does that work for quenching reactions? The ice water mixture is cold, right? So you have a little sample of your reaction mixture, you're cooling it down, you slow down the reaction. Not only are you slowing down the reaction, you're mixing it with a lot of ice and water. So what are you doing to the concentration? You lower the concentration, you spread out your reactant, so the rate at which they can react will slow down significantly. So that's what quenching means. And so once you've quenched your reaction at that point in time, then you can do an analysis. You can determine how much of your reactants left or how much product you've made. How do you explain why you have to put medicine in a refrigerator? What are you trying to do there then? You're trying to slow down the reaction. There's reactions going on that would lead to the expiration of your medicine. Okay? So there's a chemical reaction going on there.